Hello everybody. I just wanted to go over question 3 from Lab 5. It was a tricky, very tricky question. A lot of people struggled with it, so I wanted to go over it to hopefully clarify it. If I confuse you more, please just send me an email and we can work through it that way. But hopefully this helps out. So when you read the question, you realize that 1 of every 1,000 people has this disease. And the sensitivity of the test is 95%. So 95% of the time, it correctly identifies someone that has the disease, and the specificity is correctly identifying someone that doesn't have the disease that tests negative. So I created a table here, and this is what helps me with these problems. Some people I think probably are gifted enough where they can mathematically solve this in their head or in another way, but I use tables. So I create a table here where there's 1,000 total people, and one of these people actually has the disease. Now, the sensitivity of this is 95%. And this is where it kind of gets a little tricky. But this actually means that 0.95 people out of 1,000 test positive and have the disease. A side note is, when you're dealing with such low probabilities of someone having a disease or being in a group, sometimes it's best to use out of 10,000 or of 100,000, just so you're not dealing with fractions of people. It's very weird to think about. But then we can fill in this part here where there's 0.05. So 0.05 people out of 1,000 test negative when they actually have the disease. We can look here that 999 people out of 1,000 don't have the disease. And the specificity test, which again tests that you don't have the disease and you tested negative, is 90% of the time. And what I did here is I took 0.9 or 90% times 999, and I got 899.1. And we can fill this in here and we can go 99.9. So this is saying that 99.9 people out of 1,000 don't have the disease but test positive. And then we can just fill in the rest of the columns here. So 100.85 and 899.15. So we have our chart here, and this is going to help us make our big decision of, you tested positive, what are the odds you actually have the disease? Which really takes us down to just this column. So we tested positive. What is the odds that we actually have the disease? And what this is, so we use this column, and what it comes down to is 0.95 divided by 100.85. Because we have the total amount of people that tested positive, so we're in this group. So what are the odds that we're that 0.95 person? And that ends up being 0.0094. Or 0.94%. So we can see here that the chances we actually have the disease despite testing positive are very small. And hopefully this table, I attached it to a lot of people's assignments this week. Hopefully it helped explain this a little bit. But if you have any questions, please just send me an email and we can work through this. Take care.